Let M be the midpoint of both A and B. Can we then find the coordinates of the point M based on the coordinates of the points A and B? Because the x-coordinate of M has to lie between the x-coordinates of both A and B, the x-coordinate of M is the arithmetic mean of both x-coordinates of A and B. Similarly, the y-coordinates of M is given by the arithmetic mean of both the y-coordinates of A and B. This is the midpoint of two given points. If two lines are perpendicular, then the product of their gradients must be -1. Let's use this triangle to prove that must happen. Let this point here be 1 on the x-axis and M high. Let this point down here be 1 on the x-axis and M perpendicular low. So this is a -M perpendicular. Let's consider this triangle, this red one. This over here must be some sort of right angle triangle. So let's consider its version of Pythagoras theorem. Let's consider this lower triangle, this blue one, and consider its Pythagoras theorem. Let's now consider this much bigger triangle in green. We can find the Pythagoras theorem for this big triangle where this is the hypotenuse and these two are the smaller sides. Its hypotenuse is given by M high and plus this negative M perpendicular low. The diagram shows the points A, B, C, where M is the foot of the perpendicular from A to the line BC. Find the line AM. Well, we know that the line AM must be perpendicular to the line BC. Can we then find the gradient of the line BC? But because the line AM is perpendicular to BC, the gradients of BC must multiply to the gradients of BN to become -1. In other words, but we know the gradient of BC, which is half. Because the line AM is a line, it must be in the form y equal mx plus c sort of a thing. I'm going to use the alphabet K to not use the alphabet C again. But the point A46 must lie on this point AC. Hence the line y of AC must be equal to find the coordinates of M. This point M must be some sort of an intersection between the line AM and the line BC. What do? We just equate both lines together. Firstly, what's the equation of the line BC? Well, we saw that the gradient earlier was -half, and the y-intercept is -1. Since the point M is just the intersection of these two lines, we simply equate. If the x-coordinate of point M is 6, What's the y coordinate? We just put this x equal to 6 into either line that we choose. Let's choose the line AC. The coordinates of M is given by, given that AMD is a straight line where the ratio of AM to MD is 1 to 1. Find the coordinates of D. If AMD is a straight line and the ratio of AM to MD is 1 to 1, D must be somewhere here in a sense. M must be the midpoint of A and D. That being the case, we know that M is 6,2 and we know that A is 4,6. Equating each coordinate, 6 must be equal to 4 plus dx over 2 and 2 must be equal to 6 plus dy over 2. Solving just the x coordinates first. Solving for the y coordinates. Hence the point D must be given by